It's getting hairy in here. There's a lot of things happening. Look at all the things happening. Oh man, I wanted some of those purple dots right there. Oh, 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 what are you trying to do there, buddy? Dude. Okay. Okay. We're doing pretty good here. Doing pretty good. Okay. Okay, 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 okay. Most fried pickle. I want a most fried pickle. Ah, everybody went for it. Okay. Okay, we got some of that. No, oh, I thought I could make that turn and I moved my mouse too far. Oh no. Oh no. That was such a lame way to die. It's like mouse controlled where it goes toward the cursor, right? But if you try to 180 your mouse, then your guy stops turning because he's trying to go backwards. So you can't panic, basically. Can't panic. That's what we should make a better slither. That's what we should do. Right? Isn't that what the world wants? So, in this video game that we're making, we have this file format for our animations. And it's a text file format that I made a really long time ago, probably for The Witness or something. Although, yeah, I would kind of be shocked if we never switched it to binary for The Witness, but maybe we never did because it didn't matter. But anyway, we have a lot of animations in this game, and loading this data is slow because we're parsing floats. We could speed up the float parser, but the better way to do that is to not frickin' parse floats, right? Save binary. But, okay. So this originally was a super dumb format where per node or per keyframe, we're saving out for each node what the transform is, and it's just position, right? Orientation as a quaternion, and then scale 3 by 3 matrix, which is almost never used, right? It's almost always the identity matrix. So that's obviously really dumb. Now, someone on the team a month or so ago, a couple months ago, probably at this point, went in and added this thing to the format where like you just mark these little lines with a less than if they're the same as the previous one. And that doesn't reduce the number of lines in the file, but it makes the file smaller data-wise, right? And it probably makes it faster to process. So keyframe 61, all 3 of these are the same as these probably, because this probably goes all the way back to the beginning, and then, you know, these are changing, but this is still an identity scale and so forth. Now, I want to make these faster to load, and I also want to make them smaller. And the first step of making them faster to load might actually make them bigger because of this. Because the absolute dumbest thing is just save out the transforms again, right? But once we do that, then we can start doing some stuff. So for example, to do this kind of a thing, we could just have a flag on each node, or each like on each node that says this node's only got 1 value, right? And it's the same, right? Like a constant node value, right? For each of these 3, like constant position. And that might get us back in the realm of the that'll probably get us shorter than the text version, but then I don't think we're going to do this today, but like we could start thinking about animation compression and stuff like that. Like we might be able to do something simple to just drastically reduce the amount of data. Now, that said, there's like what's in the file and what's in memory. And the thing is, I want to like load all these packages into memory, and then I'd prefer to just use the data from those packages directly when we play the animations. So like if there's a constant channel, I would like to be able to say, okay, when we sample interpolated between frame, 17 and 18, just return that constant anyway, right? That's maybe an extra different step. I don't know. And then there's a whole other step of, I guess what I mean by extra different step is we could just load this format, and if it's flagged as constant, just unpack it into memory as a bunch of constants, right? And waste all that damn memory, or as a thing. And then later on, when we want to point at the memory inside the package instead of using it directly, we can then change the sampling code to do that. You know what? I'm trying to decide. Maybe we should put this one on YouTube, and then maybe I should try to do that explanation better and turn on the camera. I don't know. What do people think? I could start it over and explain it again. Didn't Casey do a really good animation system? Yes, but we're not using that. And we don't, it's a different thing to make a product that runs on everybody's game versus a thing that's just in yours, in your own programming language. No cam, yes cam, no cam. Okay, here's what we're going to do. Because my brain, while I was explaining that, I was feeling that my brain still isn't totally turned on. So I'm going to turn on the camera, and in a minute, I'm going to have a little bit of snack. We'll hang out. We'll answer questions and stuff. And then in a minute, I'll do take two and start it over. And then we can at least try to YouTube it. And if it sucks, then it sucks. Yeah, Worm Game is very slow, man. So how is everybody today? Substream? This isn't Substream. What are you talking about? It should be Substream because of the tremendous value we are going to drop. Anyone have any programming questions about what we've been doing recently? Anyone? Anyone? No one really has much to say. What is the typical structure of a game engine? That question is completely meaningless. I don't even know how to answer that. Except to say the most useless thing, which is the typical structure of a game engine, is that you have a loop where you read input, you simulate in a way that responds to that input and modifies the world state, and then you render the resulting world state. That's a video game. Like, what do you want me to say? Why your own animation format? Well, as compared to what? Like, what do you think we're going to use? What are the node names at the top of the file? These are how we ensure that we bind to the mesh correctly. We maybe don't technically need these. They may be helpful for debugging. I don't know. We could talk about that. When is okay to work for other people's projects? I mean, almost all projects require substantially sized teams, so the answer is it's almost always okay. Otherwise, nothing would ever get done. This animation is exported probably from Maya. Do I think the game size in megabytes has an impact in user experience? I mean, the things that impact user experience are concrete things like how quickly does it load? If it's big but it loads very quickly, who cares, right? Doesn't stuff like FBX have its own animation format? I mean, maybe, but it's really complicated and does a lot of stuff we don't necessarily really care about. And it's certainly, so the thing that you have to keep in mind is what we want to be able to do is load this format and then frickin' use it, okay? Like pointing directly at the memory. You're not going to do that with an FBX file. That's just not how it goes. Like FBX is not, this is the thing people have to understand about file formats is like different formats have vastly different purposes. And if the purpose of the file format does not match the way that you're trying to use it, you'll be in for a very sad time. Like what's in a game engine is a really complicated topic that, yes, you can find a large amount of information about that question on the internet, most of which is not very good information, but welcome to the internet. So we did this video the other day that we put on YouTube, and man, the compression was horrible. I don't know. So if you guys are watching me on Twitch right now and you see me down in the corner, does that look like super compressed or does it look fine? I mean, I guess it depends on your local connection. I guess I can watch on my own page here. It looks to me like it's not that bad. But then So my upstream bitrate is fine, but then we upload it to YouTube, which is also supposedly 1080p quality, and it looks horrible, dude. And we plan to add compression. It might be worth doing, but that's probably a later step. We need to revamp everything else about it. So I think I'm going to record locally this time for this. Do I have space? 100 gigs. But we're in the red. Let me, I should take a minute to delete some files. And then we can start. I mean, the video is not going to be 100 gigs, but all right. Size. Got a lot of wave and FLAC files. Delete. I'm just deleting some stuff from my downloads. Oh wait, this is my documents folder. That's the wrong place. Downloads. Size. I've got a 3 gig Ubuntu. NVIDIA drivers. Sidney Coleman, quantum mechanics in your face. I'm just going to delete some more files. Let's run Steam and try and delete some games real fast. Oh, wait, you can't launch real fast. It's going to take 20 minutes to start up. Supraland. 16, is this an expansion pack for Supraland? Like, what's going on there? Okay, what? Look at all these games. I never played Quake Champions. Dude, I don't know. What's big here? Tell me. Gotta delete that Witness game. See, most of these games are real small. Oh, do I have Battlefield? Oh, Battlefield. Uninstall that shit. Like, I played that for a week or two just to, like, work on my... How did that go that fast? Oh, because it's in Origin. It, like, didn't even... That's just a shim for Origin, right? How do I uninstall? I guess it's not downloaded anymore. I guess it did delete it, supposedly. Okay, dude, I don't know. I hope this is an exciting remove program stream so far. Filter by, sort by. Like, what was wrong with the old Windows interface where you push above the column? Like, that was fine. Why is this over here instead of here? It's like user interfaces have regressed tremendously. Apex is 70 gigs and I'm not even playing. I might actually play that at some point. I mean, there's no point in removing any of the rest of this stuff when you've got a 70 gig file. You know what I'm saying? Yeah, like look at this. Look at this is such a bad interface. Soundtrack by Twitch. Okay. Let me let my tea finish steeping, then we'll maybe start. I mean, at some point, I just need more storage on this PC, although it's probably about time to transition to a new PC. I have like a 16 or 32 core Threadripper that's just been sitting in my hallway for 2 months. I guess when I move, that's going to become the main PC probably. Better order a new PC soon. No, I mean, I have one that's pretty new that I just never switched to. So we will give that a try. Oh, good. Thanks, Origin. I really care about this. Bye. All right, so let me get ready. Got a little bit of milk. Got a little bit of honey. Got a little bit of tea. I'm going to swish the tea around a little. I mean, the majority of the space on this machine is the Sokoban repository. Like, if I do this, let's watch this count up. Still going. Still going. Okay, so the reason for that is because, when you're doing game development, you tend to have source files hanging out, right? So you have a Photoshop file, and if that turns into a texture in the game, the texture in the game is going to be compressed and maybe even down-resed, and it doesn't have all the layers of the Photoshop file and whatever, right? But you want to keep the source data in the repository, so... This is just how we do it. Why is adding file sizes so slow? Well, there are 720,000 files. How long does it take you to add 720,000 files? But it should have been faster than that. It's true. It should have been much faster than that. I don't know what they're doing that's so slow. Can't you just get the file size? I mean, typically the file size is stored in the directory entry or somewhere near there. So you don't have to actually open the file typically. I believe on Windows that's the case. Yes. Okay. I'm going to do a local record so that we don't suffer. Oh, let me close this. Actually. Okay, maybe we can go. Today I was going to work on the animation file format of the game, and I'll spend some time explaining the background behind what we're doing, and then we'll talk about specifically what we're doing. Okay, so this game has animations in it, right? 3D video games, they have meshes. Let's go to a nicer looking level. And some meshes are static and still, like many of the things in the scene, and some of them move, like this character who's walking around, right? And I can slow it down so you can see him like animate more slowly. I want to get a good... So, so somehow we need to make this happen in the game, right? Like, how do you do that? What's the deal with how characters move around? And, well, we kind of know that meshes are a bunch of 3D triangles. So if I select this guy, you can see all the triangles, right? And in a 3D authoring tool, someone who makes the animation can just pose the guy in a bunch of different poses, and then you can play them back And maybe if he can make enough poses, it looks smooth, right? Kind of like like claymation or something. You could do something like claymation. And in fact, older games, that's how they worked. So if you go back and play original Quake 1, for example, which had 3D mesh monsters, it was playing back animations on those guys at, I believe, 10 frames per second. And the animations were just arrays of the vertex positions. Like, this is where the vertices are on this frame. And they didn't even interpolate. Okay, so one problem with doing things this way is if you have frames of a guy running and you try to interpolate all the vertex positions linearly, because you don't necessarily have a better idea how to do it, it doesn't look very good. In fact, it looks freaky and bad because things are like squishing around in ways, I don't know. It doesn't look like anything that you want. So we came up with this thing called skeletal animation, and I have a way of showing the skeleton, I think. I don't remember what it is. We have all sorts of debug things. Maybe I took it out because we never used it. Anyway, I'll just explain. So the idea behind skeletal animation is you have all these things called the bones of the guy. They don't really correspond to human anatomy bones, but they actually roughly do, right? And then, so if there's one bone for the upper arm, let's say, then all these vertices on the upper arm can be described by like where they are in relation to this axis that goes down the arm, right? And then if you just describe the motion of that arm bone, so firstly, it's a lot less data than describing the motion of all these vertices, right? But then secondly, if you put in more information like how to rotate the arm bone, right? Like the arm bone is like a full 3D transform, right? So you can rotate it and then all these vertices would rotate around it. And so you can get motion that you can't really get if you're linearly interpolating all the vertices, right? So this is very common in games now, to do skeletal animation in that way. And that's what we use for this game. There's other animation things that games do sometimes, like morph targets and whatever, which basically are sets of vertex positions in their simplest form. But we're not doing that right now. Like for this game, it's like, this is a typical camera distance. These are the characters that you see. And so we just need things to look good at this distance, right? Okay. So how do you do this? Well, the mesh data for this character doesn't just contain coordinates for all those 3D vertices. It also contains a description of what bone is it attached to and, where in relation to that bone. Now, that's not even all, because if every vertex was only attached to one bone, then everybody would look like a robot, right? But we'll see how well, we'll see how well we can see this here. But, as this guy moves, you can sort of see like, he's kind of, I don't know, like squishy, for lack of a better thing to say. Like he's not just a bunch of rigid bodies moving around. Like the torso bends and the cloth on his shirt down there kind of bends, right? And even though his arm is made out of like the geometry doesn't seamlessly blend into each other right now, that's not an animation thing. That's just like the way he's modeled right now, right? So how do you do that? Well, the way that you do that is you attach each vertex in the mesh to multiple bones, and you say it follows this bone by 30% and this other bone by 70%, right? And that's how you get these blends, right? You can crossfade. If you're going from the upper arm to the lower arm, then in some parts of the elbow, you have things that are like 80% upper arm and 20% lower arm. And then you have 50-50, right? And then you have 20-80. So you get like a crossfade of how attached to each bone things are. And that's how in this kind of video game animation, we simplify this kind of thing. And we're really not doing anything in this game more complicated than that. We might later, who knows. There's all sorts of other questions that we're not going to talk about right now. Like right now, this guy's in the middle of his idle animation, right? You can see him, he's sort of hanging out, and then he starts running, and then he goes into a stop, and like blending from one animation to another animation is a whole different operation that involves, you know, interpolating that skeleton between those poses. Okay, but this guy looks weird at this angle. But what we're going to talk about is just the playback of a single animation. So we've got a file format that we've been using forever in the game. It probably goes back to the Witness, and this might be the file format that we shipped in the Witness. And I made it a text format because I just wanted something that was easy to debug when I went and looked at it and whatever. And it's got a version number at the top. It's like, how many frames per second is this animation meant to be played back at, right? Of course, you could speed that up and slow it down if you want to in the engine, but you have a reference. This is how many nodes, and this number of nodes is like, it's the same as bones. I just called it nodes in this file format. This character has 215 bones in it. You might think that sounds like a lot. Actually, we have characters with a lot more. Because if you have like, you know, bones don't mean human anatomy bones, right? They're anything you want to animate. So like the ponytail on top of his head probably has some extra bones in it. You see it shakes there separately. And like, if he had like, I don't know, a dagger hanging off his belt, like that would be at least one extra bone. And then also just to have good character animation, you know, you've got like multiple per finger and all these things. And more than you would think, like in the spine. So, so that's the basics here. And so this file format, this is how many samples we have per node, which is basically just the frames per second times the duration of the animation. Like this animation is 77 frames long. Maybe 76 actually, because the last one is like an endpoint. And then this is a transform that describes how to get from like the game's coordinate system into the coordinate system used by the animation system. And it's just, you know, it's just swapping some axes around, right? So Z to X and, or sorry, X, whatever. Different systems use different coordinate systems, and this is just a transform for that. And then we have the actual animation data. So first we have, here's what the bones are. Bones are expressed in a hierarchical manner, right? So like, I don't know, like a finger has parent 43, which is probably this one. And that's parented to here, and that's parented to 26, which is probably way up here somewhere. Anyway, the reason you do that is because, you know, naturally, physically, if I move my upper arm, it's hard to do, but if I move my upper arm without moving the rest of my arm, the rest of the arm comes with it, right? And so if you talk about how to store data or how to interpolate data, if somebody's moving just like this, you want to get all this movement like for free. You don't want to have to separately store all these bones moving, right? You wanted to say, oh, this bone is moving. And so there's this hierarchical organization to the bones, right? And typically like a hip bone is the root somewhere. This is all very standard, right? This is how animators animate. This here is a very verbose way of saying we have these nodes. Here's some names for them, and here's the parent. And the parent is whatever index the previous one is here. So there's basically, this is sort of a weird way of listing out two arrays. One is the array of node names, and the other is the array of node parent indices, right? And then we have, for each keyframe, which again is samples and keyframes here mean the same thing. Keyframe, this is a little bit of a misused word because keyframe in an animation package kind of means a different thing. But from the way that we were authoring the code, this made sense. Whatever. This is like sample 0. Anyway, frame 0 of this animation has then for each of these, how many did we say? For each of these 215 nodes, we write out the full transform of the thing. But we don't even, so a transform in 3D is a 3x3 matrix, right? But we don't even write it that way. We write it like even more decomposed than that. Because when you want to interpolate stuff, you want to think about interpolating positions and interpolating rotations and interpolating scale, right? It comes out that way. And so that's how we stored it in this. You don't have to store it that way. You could store it as a 3x3 matrix and then like decompose the matrix again. The problem with that is if you have matrices that are results of many operations, you can get confused about what conceptually is scale versus rotation. And then you might end up interpolating that differently than you otherwise would. It's a complicated issue. We're not going to worry about that. But also decomposing matrices on load, that's like an expensive operation. But this takes more space, right? So this is logically a 3x3 numbers worth of information, 9 numbers, but we're using 10, 11, 12, 13, 14. We're using 16 numbers to represent it, right? So these 3 are position. These 4 are orientation. That's a quaternion, right? Again, that's questionable from a data format storage standpoint, but we'll talk about that in a bit. And then orientation right here. Okay. Now what? Okay, well, basically there's an array of these, right? There's 215 or whatever I said. And this is in bone order here. So if I jump back up to the top of the file, the order that these names are in is the order that these are in, right? And then if we go to later keyframes, you can see, so this is like a lot of data, right? If you just write it all out. Another person on the team recently did a little compression-ish thing where we say, hey, if it's the same as the previous frame, just write this. And then when we load it, we can just copy the data from the previous frame. And that way the files aren't so big. But the memory footprint is just as big, right, after we've loaded it. Okay. This is not a very good file format for a shipping game. I guess we used it fine in the witness, but you know, it's because there was so much work to do. For this game, we've got more animations, and we just want to make the format better. Oh, it's position, orientation, and what? Sorry, this one is scale. So this is a 3x3 scale shear matrix, which is actually also overkill because to represent scale and shear, you only need 6 components. It's like an anti-symmetric. Well, if it's anti-symmetric, you only need 3. But this was like, I was making this file format. I was like, I'm going to be super paranoid about what goes into this file format and just make sure we don't have any problems, which is why we wrote this out. So basically, this is whatever whatever happens when you take the scale shear and multiply it out to a 3x3 matrix. It's like way more data than you need. What had bones animation in the witness? All the doors and elevators and stuff. And the character. So, the problem that I had then was when I was looking at packaging the game, the animations that we have already is like a gigabyte, and we're not done. That's kind of a lot. Of course, we could compress that down so it's less than that when you install the game, but even then, if we want to keep all the animations in memory at once, which we probably do, because it simplifies things a lot, that would mean that that takes a gigabyte of memory, which is way too much. But there are a lot of ways that we can reduce this. So firstly, as I said, so this step here reduces the on-disk footprint. It doesn't reduce the memory footprint. Secondly, I don't know. And now I'm going to confuse myself by getting into two different categories. Let's stick with talking about the on-disk footprint for now, because that's simpler. Actually, let's even go back one more step. So I was talking about problems that we have. One problem that we have is size. Another is these are just slow to load. It kind of hitches when we load because we're parsing all these floating point numbers. We probably could parse them faster. And we just haven't done that. But even so, like parsing a bunch of floating point numbers is a waste of CPU. All you want is the exact float that was written out, and floating point formats are very well defined. IEEE 754 32-bit is like the way to go. Maybe even 16-bit. There's like half float formats now that we could use for positions if we want later. So writing out all these digits and then loading them back in is a waste. And so also, if you look at just in the file, how many characters does it take to store one of these numbers? It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the space is 10, right? A floating point number, a 32-bit floating point number is 4 bytes. So you already get 40% of the size just by saving the binary. Now that said, if we save the binary, then we can't do this that easily. So what I'm going to do is I'm going to start developing a binary format, and it might actually stay the same size or get bigger because we lose this ability, but then we'll go back in and put that in as a later step. Now, another thing that's bad about this file format is the way the data is saved. I was making decisions way back then, like how should we save the data? Oh, it conceptually makes sense to store it keyframe by keyframe because, I don't know, you could splice two animations together by adding more data, or just if you wanted to debug and look at one frame, you see all the data right there. The problem is this isn't how you want the data to live really when you're playing back the animation. I think it's unambiguously a win to have it work such that you list all the transforms out for each node, right? And why is that? Well, first, you're always interpolating between, like when you're playing back during the game, you're never on frame 17 or frame 18 exactly. I mean, I wouldn't say never, but almost never. You're usually at like 17.1 or 17.35, right? And so you want to interpolate between 17 and 18. So you're always looking at two neighboring values at once, right? So that's one reason to kind of pack them together a little bit. But another reason is, again, as we go to a binary format and as we start making this smaller in memory as opposed to just on disk, you want to say things like, hey, there's a flag per node that says, hey, the positions are constant, so we're only going to store one position, right? Or the X and Y of the position are constant and only the Z changes, so we're only going to store the Z, right? And so if you do that on a per keyframe basis, you have this very, you don't even, like, knowing what's the offset to the data for each node is hard. You're like, it's kind of random. I guess you could store it like in a global array of like, what are the offsets, as long as you didn't change them. right? But it's just better if you say, look, the positions are X, Y coordinates, or I said Z. Okay, so the positions are just Z coordinate changing. So here's a whole array of Z coordinates, and you just know how big that is, right? It just seems easier and better to me at this time. We'll see. Sometimes we change our minds about these things. So I also want to change the way this is stored. So this whole thing is like an array of frames where each frame is an array of nodes, right? And I want to change it to an array of nodes where each node has an array of frames. And I think that's how we're storing it internally in the game anyway now. So it's like, yeah. So in what order am I going to do these things? I don't know. I'm just going to play around. I think the very first thing to do, we're just going to write out a binary file that has the data moved around like this. And then if that's all we get done initially and we take a break, that's cool. And we can come back later and do more. That's pretty easy, honestly. As we do that, we can be a little bit forward thinking about like, hey, we're gonna at least keep a node field or a flags field per node, so we could say things like the scale is constant or something. We're gonna have to see how that evolves, I guess. Now, once we've done all that, there's longer term things we can do, right? So this idea of like only the Z coordinate is changing and, you know, the scale is constant once we set it up for the first frame, that kind of a thing is a very specific, simple way of just compressing the data that's in these arrays. And you can have, I mean, people in history have thought up of all kinds of data compression, right? And you could leverage any of that. One that, you know, Casey did and Granny was just using I mean, he sort of, I guess he did some Bezier curve stuff, but I also just remember him doing, I remember him saying a long time ago that he actually found that parabolic segments, this might be totally wrong, but what I remember him saying was that for most animations, like fitting with parabolic segments was totally good. But anyway, you could imagine, so if you imagine line segments, right, because that's easier to think about. If you just could, say you have this 77 frame animation, but you found that you could fit with only a very small amount of error, the first 15 positions for a node to a line segment, then you could just say, here's the starting value, here's the ending value. It goes for 15 frames. And interpolate if you're between those. And that would be a lot smaller than storing 15 positions, right? And so you can start doing that kind of thing as well. Anyway, any starting questions about this before I go? The next step is just going to be, let's just start making a file format for this, right? Oh, I should say some more things about applications. I might have kind of said this, but the goal eventually, when it comes to a shipping game engine that you want to be fast, you want it to be able to load assets and use assets and just be good at that, right? This is an asset. A data file is called an asset in game terminology. You don't want to have to like do all sorts of, you know, C++ or RAII garbage upon loading the thing. You don't want to like instantiate a bunch of objects when you want to load the thing because that's not fast. You want to load the data and you want to use the data packed into the file that you loaded. That's the best case, right? So when we have this stuff packed into these arrays, initially when we load the file, we're just going to like unpack it into other data structures, right? But eventually we want to just be able to point at these and say, if you want to sample a position, here's an array of positions, dude, and just read between them and do the thing, right? And so this file format is going to be tailored around that. And so one thing people have been asking is like, what about this format from Autodesk, or what about that thing? And the answer is, those are all way too complicated, and they're not made for what our game engine wants to do. And they're especially not made to be loaded and used in exactly that way. So we're making a format that is good for what we want to do. So the thing you guys have to understand, so people in chat are mentioning like various animation formats and scene description formats. And like the thing you have to realize is different formats have different purposes. Like describing a scene generally, or being able to save out everything an animator might want to do so that you can load it back in somewhere else. Or even like, an animation format that was really good for cut scenes in a video game is going to be pretty different from something like this, right? It's a different purpose. Isn't it premature to optimize the storage representation before changing the actual animation method? What? I don't know. How are you going to play back data more efficiently if you don't have different data? I don't know what you're asking by changing the actual animation method. That question doesn't make sense to me. How are these files produced? We have an exporter plugin. This was exported from Maya, for example. Do I see a way to use relative pointers here? There's no pointers in this data. If you want to be able to use the raw data, you can't have compression. Well, you can, but then you want to decompress, which still could be a clean operation, right? So decompressing on load to a larger buffer is still better than... Okay, well, actually, no, I assumed it based on the question. So if you mean you can't use compression, meaning like you can't use some kind of entropy coding like you have in a zip file or something, or like is built into the new PlayStation, you actually totally can. But it's like you're doing a buffer to buffer copy that decompresses before you can use it. But that's a clean operation that goes from one block of memory to another block of memory where they're both of known size, right? That's different from... I'm iterating over all my nodes and doing a bunch of C++ new operations to like do a ton of fragmented weird memory crap to like fill it. That's a totally different thing. I also need to change the exporter. Eventually, yes. So the plan is make the binary file format, be able to save out. So first we keep loading from this text format, and then we save the binary file format. And then we can make the engine check when it wants any animation if the binary exists and is newer than the text format. And if that's not the case, it can generate the binary from the text format. But then it could always load the binary. And once the engine is always loading the binary files, then we can change the exporter. That said, before we change the exporter, it's probably a good idea to figure out a lot of this compression stuff to get the animations reasonably small. Because, you know, that's like if you if you start exporting files before that's in, then they're bigger, and then you would have to go re-export them. That said, it's not that bad because it's probably not going to be worse than this text size. So, you know, maybe we could do the switch over at some point. I mentioned moving away from frames. No, I didn't. This is still a frame-based animation. I talked about changing the order in which the data is stored. And the playback already uses things in that order, but it doesn't really, like the playback probably doesn't care that much yet about that aspect of the order in which things are stored. It just makes things easier or not easier depending on compression type. Oh, and I said earlier, you know, if you mean entropy coding for compression, it's like a buffer to buffer copy. If you don't mean entropy coding, if you mean that kind of like polynomial approximation of the animation data, we would still be using the animation file directly. It's just we would be reading those coefficients every frame and calculating based on them rather than, you know, just a flat array. But we would still be reading the data out of the file. Oh, maybe that's what that other viewer meant by moving away from frames. I see. Maybe that's what that meant. Can't you dump the data from the game memory as is? Right now, we don't store it completely contiguously. We maybe should, but we don't yet. Also, though, like you want to be able to write the file format. How do I say this? Like if your data structures have any pointers at all in memory, then you have to do something where you're kind of flattening it out when you write the file, right? Now, ideally, you do as little as possible. That's what makes it fast. I don't know. I don't know how to say that. Is it a good idea to still support plain text? Well, that was part of the for debugging and versioning. I mean, that was part of my original theory, was that plain text would be better because I could read it and for source control. And the reading part, this honestly isn't that readable because it's a lot of just frickin' numbers, dude, right? So I don't hardly ever do that. And in terms of versioning, the thing is, if somebody edits an animation and they save it out again, I'm not sure we save that much by being able to diff from the previous thing because nobody really, because this isn't a hand-authored file, people don't really care about the diff from the previous version. I don't know. Like I haven't found these things to be useful in practice, is what I'm saying. Okay. Someone's saying what file extension? Well, right now we have, it's called .keyframed animation for the text version, and that's a really long name. I might just go .anim or something. And the reason why is because we have 2,700 of these files right now. So we're storing that 2,700 times. just not, I don't know. Anyway, let's just get started on this. So we do all this stuff where we load. So I haven't looked into this code in a while, and so it's going to be new to me a little bit. So here's our loading the file, the text file. And we do some stuff. This is weird because this is from before we made the text file handler, because the text file handler would handle this. Whoops. What just happened? Emacs. This like bracket version thing that's at the top, the text file handler does that. So I don't know what's going on here. Okay. So this is just loading all that stuff at the top of the file, etc. And let me find where it loads that matrix. Where does that get stored? And it also does some footstep stuff down here. We might actually factor this out because we're not storing that in this file, and I don't think we want to. This is like some computations that we do. What we could do for now, though, before we even worry about that, and then this is sound events, which is like, okay, if you want audio to happen at a certain point in an animation, that goes in this file. I'm not sure why we didn't put that in the regular animation file. We could talk about that. Let me write that down. Okay. So, I think to write a binary file format, so we're setting the duration here. Yeah. I don't think we want to do float duration. I think right here we could say no check-in. So this anim is, where even are we? Yeah, sampled animation. So we could say save binary animation binary file name anim, right? And what's binary file name? Strip the extension off file name, and binary file name is tprint. Just put in .anim. If we think of something better later, we could do that. I'm sure other people in the world use that file extension, but we don't care. This is just for our game, and we're not going to use anyone else's .anim. Yeah. Okay, so save binary animation. We'll just throw it down at the bottom for now. We might put it in a different file later. Who knows? File name is a string. Anim is a sampled animation. And we're just going to go. You guys who saw the other stream know what we're going to do here. It's just going to start out pretty straightforwardly. String builder. Oh, not pointer. We're going to go defer free buffers on the builder. And then At the end, we're going to go write entire file. Success is write entire file. File name builder. If not, success log error. Unable to write file whatever, comma file name, right? So that's very simple. What do we do then? Well, let's go back and look at our file. We're just going to start by saving out this header information. We're going to ignore all the nodes and all this stuff so far. We just want to get started. So save binary animation goes version number. We're going to make that 32-bit. Should we put a magic number? I think we should, right? Okay. So we're going to put builder cast U32 animation file magic number, right? And then version. I don't know what magic number to put though. I really don't. We have some excellent magic numbers in the past. Anim. But the problem with using a magic number is then you really collide with other people. If you use anim, I don't know. Excuse me. Wow. I'm over here dying of COVID right now. Yeah. Simp AF. No. I don't know. Okay, well, file version is 1 right now, and we're probably even going to increment this over the course of our work. We already used simp as a magic number. Let's just use anim with a capital A. That's maybe less likely to collide with people. We're going to go run. Right. So this assumes we're a little endian. And again, it's fine. We need to go do a whole endian pass later, but we don't even have a big endian machine at all these days, so we're not worrying about it. You know what we could do? We could at least abstract this, right? Right, so we could do this. Maybe. Oh, right. Wait, what? Oh, because it's a, yes. All right, so now, oh, I changed something before the stream, guys. I didn't like that this frame rate was a 64-bit integer. That has nothing to do with anything we've been talking about. Same with parent index. I changed that to 32-bit. Okay. This is all stuff I did before. Sorry for the distractions. Oh my God, this is all stuff I did before the stream. Not enough arguments. Start from memory. Handler. We did this on the other stream. Anim.name. What's the other parameter? It's like a... Start from memory. Short name, full path. That's just for error reporting. Okay. Redeclaration of filed. Guys, I should have before you start the stream. Let's call it events. I bet I have this on all of them, right? No. Okay. Great. Great. Did I destroy everything or does it still run? I destroyed everything. You know what we're going to do for a second? Actually, yeah. All right. Let's just, you know what we're going to do? We're going to revert this. Oh, it's in a subfolder, animation. Going to revert this. We can do these changes one at a time later. All right. We're going to make sure that compiles and runs. Okay, and now we're going to go back and do this. Now, this might have been what was crashing it, but if it was, then it'll be much easier to figure out because we're not randomizing with all these other changes that I typed this morning. Okay, so again, we put this part, no check-in. Save, binary animation, binary file name, anim. And how do we get the binary file name? F is path strip extension file name, and binary file name is tprint whatever dot anim, comma F, right? Okay, so that ran, and it should have saved some files out, right? So if we go to our actual thing, that is it. Steam is annoying me, dude. Shut up. Okay, we wrote out warrior active idle 01.anim. It's 8 bytes. It's 8 bytes because it's just got a magic number and a file version. So great. That means we already have our binary file format. We just need to make it better. Right? Okay, so frames per second. We're just going to make all these 32 bits, right? Anim dot, we're going to look up what these variables are actually called. Anim dot num nodes, right? Let's call it bones. The bones are their money, and let's focus on terminology, right? Num samples, right? Let's make these S32. I'm going to learn from our other file format that we really do want these to be signed, even though it means we have to check for less than 0, but that'll be good. Okay, and then this whole base transform thing, are we ignoring that right now? G matrix. Is that the G matrix? Oh, it is. It's 4 by 3, right? Or 3 by 4, depending on. Yeah. So the reason you do this is because you want to have translation in the matrix, but you don't need a fourth row because there's no like perspective in it. Now this could be matrix 4x3 even. Do we have, okay, G, how did I end up in this file? G matrix, yes, we say read matrix. So we have a mate 4x3 thing here. So we could just look at that. Okay. We're just gonna append to the builder anim.g matrix dot mat 4x3. I mean, this is a little bit redundant, but it's a little, because it's the same first component as this, but it's self-documenting, saying we want the 4x3, right? Like that's just, you know, we're just going to write these out straight from memory as opposed to like looping or whatever, right? What else? We could start by doing the nodes and the parents. However, I think array of 16-bit parent indices num bones long, and then array of node names num bones long prefixed by, we could even say you just shouldn't have more than 8 bits of string, 1 byte string length, also 0 terminated, 0 not included in length. That way, so we can just point at these names. All that said, maybe we shouldn't bother with this since we only use these names to verify we're attached to the right mesh, and we could do that with a checksum question mark plus date. A checksum plus date would be like, okay, let me write that down. I'm going to do this just because, like, hey, it's an exercise, but it is what it is. I don't think it would be very good for Casey to do a programming class in a programming language that nobody who takes the class has access to. If I were him, I wouldn't do that. Okay. Also, I'm pretty sure he's very far along in terms of writing the code for it. So it is what it is. Okay. Yeah, let's just do this. So we can go look at anim.nodeinfo. Assert anim.nodeinfo.count is equal to numbones. Actually, okay, and then the bones are their money. And then number of samples is just anim.numSamples. So this is a thing, right? We're putting this into the builder, Bob the Builder. And if somebody goes and changes this type later, we don't want our file format to like mysteriously break and nobody figures it out until 3 months later when someone saves a new one, right? You've got to preemptively notice problems like that and catch them. This is the difference between a senior programmer and a junior programmer, right there. All right, you get it? Okay. So the bones are their money, and so are the worms. All right, so for all the node infos, we've got parent indices, and we're going to say let's just do this. And I mean S16, right? Put builder index. So that's just a flat array of parent indices. Boom. Boom. And then the names. We're gonna say if name is it.name. If name.count is greater than 255, let's just do this because we're going to modify it. Count equals 255, log error, name whatever is too long, truncating the length to 255 characters, comma, name, bone name. Okay, we're going to put into the builder the count, right? Cast U8. Count equals 0. All right, so we put that. We put append to builder name.data by count, right? And then put builder cast U8 0, extra terminating 0 for talking to C. Do we really want to do that? I don't know, but because it takes space in the file. Whatevs. We can remove it later if we really want. Frames per second is not a member. It's called frame rate. Frame rate. Yes. I should make this append function take a void pointer so we don't have to do these casts, but that's not what I did. How many times have I implemented binary formats? I don't know. Like, I go through phases of not doing that at all for years, and then I do. So what do you want? Oh, hey, let's tell the hot loader not to report anims getting saved out, but we can see that we did. Let's pull this up. Run tree, anim art, data, art, animation, Soko Warrior, animation, date modified. Here we go. So you can see we've got this is all the parent indices, and then this is all the node names, and they are just in there. Cool, cool, cool. Now this is already 5K. Okay, this is sort of the problem with storing all these names and why we might not want to do it. This is already 5K. If we have 1,000 animation files, that's 5 megs. And we already have 2,700. We might not be using all of them, but let's say we have 3,000 in the final game. That's 15 megabytes of just storing these things over and over that we don't necessarily need. So we might actually take this out of the format, but for now it's in the format. And the reason it's kind of redundant is that this data really lives in the mesh, actually. Although, I don't know, man. We'll see. Anyway, for now, our job is just to put the current format in binary. Sometimes you can be small brain by doing that, just saying like, look, for now we're doing this. Later we'll do whatever else we need to do to go further, but there we go. Okay. Now what? What do we do now? We start saving out the datas. So let's put this down here. Prior to that, we're going to save out datas for the node info. The actual. So node info has the parent relationships, but then it's also got, and I might, actually after saving out the format, I might want to refactor this data a little bit because I'm not sure that node info is a good way to do it. Like maybe we just want an array of names and an array of parent indices per node, right? Or, who knows? Who knows? Okay, anyway, states, right? Now, this is already arranged the way that we want it in the file, right? I was talking about flipping around the order in which things are stored, but we actually did that on load. So every node is an array number of samples long, right? So write out, let's actually, let's say we're going to put 32 bits for each node, describing the properties of the node. We could have put that up here. Maybe we'll do it here. There's no flags right now, but we want to use these things to say like, oh, you know, this one has no transform and whatever, who knows. Okay. 32-bit node flags. So those are just zeros. Write out the transforms. Okay, so 4. All right. Yep. Okay. So if we were making a debug format, we could even write synchronization markers between the nodes, but I don't think that's worth it. Is it? No. So for each node, we have an array of xform states, right? Where are we? We're here. So we're going to assert states.count is equal to, what was it? Numbones. All right. We're going to say bone. I think we're going to do a renaming pass. This started out as the file format stream, but it might be the renaming pass. If you have the string size, do you really need the \0 to talk to C? You don't, but you would have to copy the string before passing it to C. The thing is, we don't really need to pass the string to C, honestly. But I'm not going to worry about it because it only would save 1 byte. And we're probably going to remove the names altogether. I just want to talk to the animator about it before I do that. So, yeah. Okay. For each bone, write out the transforms. Okay, well, we've got these xform states. And I could just write them out, little endian, right? The thing is, these are maybe padded. Let's just assert. So again, we're being super dumb here. Actually, no, I don't want to write the code this way. Because remember what I said about wanting to be able to compress things. So we're just going to do multiple passes over the data. We're going to write out positions. We're going to write out orientations. We're going to write out scales as separate arrays. which means, I mean, we could put this aligned just to make sure that we don't pad, but it means we're not really going to try to write this directly because we won't want that eventually anyway. So we're going to say, we will write the positions in binary. Wait, didn't I put like a, no. We have an append struct, but it was in some other code that we did. So I'm just going to do that. Okay, so we're going to do that. First, an array of positions. Next, an array of orientations. And I think that we're going to want to refactor this storage to be more amenable to this kind of compression. Maybe that's what we're going to start doing on the rest of the stream. Because this array of X-form state thing here is not what you want when you want things to be small in memory. We might want to concoct an X-form state later, right? Yeah. Okay. So we're going to do the orientations, and we're just going to write them out. And this is a little bit copy pasta, but it's going to change, right? We don't need this assert multiple times. Scales. And this is when we're going to be writing wasted information most of the time. Okay. Let's see how big that comes out. States dot count. It's node dot states. Translation is not node info. Oh, yeah. Guys, I didn't do the inner loop at all. Yeah. XX. The magical XX operator. Okay, great. Dang it. 911. What is it under the window? Line 911. Assert node.states.count is equal to numbones. Really? Oh, not numbones. No, it's not numbones. It's numsamples. What am I even doing? That didn't even make sense. Sometimes your code is wrong and sometimes your assertion is wrong, but then your assertion is part of your code anyway. All right, so we now have warrior active idle.anim. It's pretty big. Yeah, it's twice as big as the actual keyframed animation file. Why? It's because we're writing out all these damn scales, right? So I think the simplest thing to do, and there's like lots of low hanging fruit here, right? So like I said, we can detect duplicates. How do we want to do this? Because I don't want to start doing super fancy stuff until we're actually loading this and playing it back. But those frickin' scales, dude. So firstly, if we're writing a scale, we could write only the components that we need, right? I could show you guys what shear matrix. Whoa, this is not, I want a 3D specific. What are you guys doing? I want to show you guys. Okay. Maybe. So if you look at this, so you see here's a matrix, and a lot of it's 4x4, right? You only need 3x4 to do 3D affine transformations, which is transformations without projection, right? And then these three, the diagonal is known to be 1, and this column is known to be 0. So there's really only 6 components, right? We're writing out 12. So immediately, by only writing out these 6 components, we can solve that. If in fact, now this is the question, if in fact we're not frickin' using those in the animations. Now, for most transforms, these are going to be 0. So what we could do is detect, firstly, we can detect if it's just the identity scale, right? Like I could even look through this file. So we might get lucky. Let's look in the Queen file that we loaded. Like we could look for, so this is, right, remember in the first keyframe, we don't have any values yet, so we write them out every time. But once we start doing this, I could just look for a really long line, and that would be a scale line. But like, you know what? There isn't one. I do think maybe the bird meshes have. But I don't know if the shear is, or if the scale, I don't know if it's in the mesh only or if it's actually in the animation. Let's just take one and see. Yeah, no. Okay. So this animation is not using any scale in the thing. In the thingamabobber. So see, the thing is, we can start getting into like a whole bunch of these ways of making the file smaller. But I think we only want to do that again once we are loading the file, um, because um, because that's how we know if we break something. If we do a bunch of stuff like that now and don't test any of it, and then later we start trying to play back from that data and we're sad and it's broken, then that's a harder debugging problem because you have so many questions about where it could have gone wrong. So here's what I want to do. I'm going to do the simple thing of we're still storing a scale for everything, but just the 6 components that only should ever be there, right? And then that'll get us a little bit smaller, and that's also code that we would use eventually for animated scale shear, right? And then what file were we in? Sampled animation, yeah. Okay, so here we're gonna do a different thing. Instead of writing this out, we're gonna go, let's go back. How big was our old file again? Basically 1 meg exactly. So we're just gonna get it down to, I don't know, it'll be like 700K probably after this, and then that's still bigger than we started, but not that much bigger, and we'll get it down again afterward once we're playing back from these. Okay, so we're gonna put, because this is like a scalar builder, state.scale.12. So like 1, 1, 2, 2, and 3, 3 are the diagonal elements. We're going to go 1, 2, 1, 3, 2, 3, right? And then 2, 1, 3, 1, and 3, 2. And that should be the only information that we need there. If it's not, we have some other work to do, but I actually have to go and debug some stuff with non-uniform scale somehow in the system as a whole anyway. So that's like a whole thing that we need to figure out. Okay, not build. Okay. And actually, because it's easy, we could go one more step. We could start, right? Let's just go see how, 800K. So it didn't get as much smaller as I thought. So if that went from 1 meg to 800K, if we don't ever write out the scales, we'll get it down to like 600. Which is better. I don't like being double the size. I mean, again, we're not going to ship this to anybody while it's this big, but just to show you the idea. So first, I think we want to detect the common case of when every single scale is the identity, right? Actually, this is just the shear matrix. Actually, we need the scale as well. I don't know what I'm talking about here. So let's do this. Yeah, Yeah, screw it. Let's just do it. Just for the scale. We're not going to do it for the translation or orientation yet. Or maybe we will. I don't know, dude. Maybe it's so easy that we just do it. I don't know, dude. I don't want to make a mess. Oh, but you know what? We can turn it off and on later for various things. So maybe we just do it. Okay, we just do it. All right. So here's what we're going to do. We're going to say if, so we're going to say flags is, all right, we need an array of flags that we compute here. We're going to call these the, value presence flags. I don't know. Component flag. Let's call it coordinate flags. This is a very generic thing. Now these are going to be things like, okay, translation X, right? This means the X coordinate, right? And the Y and the Z coordinate are present. Right? And same for orientation. We're just going to add a W component. Now, with quaternions, I actually don't know how to feel about this. Because I'm not sure that we really had a lot of nodes. If we go back and look at the warrior thing, or just this one, it's hard to tell because of the way the data is stored, right? But if we go to, let's go to keyframe 1 on the left and like keyframe 15, that's fine. So what I want to do is just see, so these values are obviously different, that's why we're storing them. But are any coordinates the same? And I don't think they are, right? So we're not really seeing a thing we're isolating particular component coordinates. It's more like, look, for this node, all the positions are the same. For this node, all the positions are the same. It seems like it's kind of all or none in these animations right now. So what I really want is just flags that say the position is constant, the orientation is constant, the scale is constant. And then if the scale is not constant, we could do a thing where we maybe detect, do we need one coordinate for scale 3 or 9, right? That makes sense to me. So let's do this. Translation constant, orientation constant, scale constant, and in fact, we could have like scale non-existent, and we just know that it's okay. So now we want to detect these. This is going to be an array of value flags. Value flags. Allocator is temp. We'll get a nice little bit of memory, and then we'll say array resize value flags by the number of bones. Okay, that's great. And now we want to detect the value flags. And then here we're just going to say append to builder value flags dot data value numbones times size of value flags. All right. So there we go. Now we have to set these value flags before we write them out. For each bone. All right. What about each bone? Well, we go over all the transforms again, right? I'm saying bone now instead of node. Like in my brain, I'm switching terminology. So, well, we don't want to write anything now. We want to say, okay, firstly, flags is a value flags. If num bones is greater than 0, right? Because we might get past the degenerate animation. And the reason I'm saying this is we're going to say initial value, initial pause position is bone.states 0.translation. Position and translation are kind of, right? So we're checking the initial values. Orientation, initial scale. I'm going to break the states, not stats. So scale. All right, great. Let's just even take pointers to those. Screw it. So I mean, this is kind of weird. We're going to start with all of these set. This might be a little bit of an inefficient way to do it, but whatever. We're going to do this, that, and that. All right. And then we're going to clear those flags as we see differences. And we're not even going to like try to optimize this loop in the middle, right? We're going to say, we're just going to go IPOS because we're going to be saying this a lot. So we're going to say if state.translation, ori and scale, right? We could, okay. Here's some funny shit. Do you want to see some funny shit? Instead of writing this out in a real dumb way, let's do this. Compare, which we're going to define in a second. IPOS to pause and flags and translation constant. So we're going to say if these are not the same, clear this flag out of flags. All right. And we're going to say, whoops, if those are not the same, And you know what? We can just use memcomp, actually. Let's, we don't need the full 4x4 for scale, like I was saying, right? So we're going to go mat 4x3 on these. I mean, we really want 3x3. Wait, scale, X form state. Oh, it is a matrix 3. Okay, I got that confused with something else. Never mind. Never mind. Delete that. Okay, you know what? We don't actually need a function. We're just going to say if memcomp pos size of vector 3 if this, then flags, we do that, right? So literally, if any bit anywhere in here is different, we clear the constant flag, and maybe we'll find a way in which that misfires. Or false negatives, I don't know. Okay, so let's be responsible programmers. Oops. See, okay. Cool. So we could log this then. Whoops, what did I do there? Did I confuse Emacs or did I? Oh, we don't have enough parentheses. Do we? We need to be more like Lisp. Okay, so we're just going to log for a minute. Bone whatever flags whatever it index and flags, and then we're going to write out the flags, right? So we got to go value flags it index equals flags, and then we save this here. Ooh, where did I do that? I left that hanging 966. Oops. Okay. Oh yeah. Okay. So let's fix this stuff. We're just going to list all these out. Super dumb about it. We might optimize that later. Okay. So and the reason I'm listing it by components like that is because we might want to do subsets of them later, right? Okay. Now, if the constant flag is set, now the reason why I'm comfortable doing all this is because later if we want to debug this, we just comment, or we just clear these flags, right? For every node, and then we just end up outputting all the data. And then we can try just translations, right? And once we have that working, then we turn on just orientations. So I'm actually not that scared by this, as I might be in other cases. Okay. So here is what we do if it's not constant. All right. So let's go. Flags is value flags it index. We're going to want these each time. And we're going to say if flags and translation constant, is that what I said? Yeah. If it's constant, we do something. Else, we do all this data, right? Okay. Okay. So this is scale. This is orientation. What do we do in this case? Well, we say append builder so we also know actually, here's what we should do is because the constant flag means we're going to look at element 0. Yeah. If this flag is set, we have at least one sample to look at. So we append to the builder node dot states 0 dot don't I have this append I thought dude I swear we okay. It's probably in one of the modules that I don't know where it is right now. So we append to the builder states 0 dot translation. We'll just copy pasta this for now. Again, we can make a macro for that to clean it up and make it less error prone. Oh, wait. This is a goofball. That's a major goofball. We didn't using these, so they have to be namespaced. Ah, yes, the same thing I do every time. Take over the world. Okay. Let's see how much smaller that comes out if we didn't screw it up and crash. Okay, how we doing? 148K. Hopefully that doesn't mean we did it for literally... No, because... Okay. Oh. I don't like what I'm seeing here. Oh, first I didn't declare it enum flags. That's why they're not printing correctly. Secondly, I feel like we should have scale constant on all of them. But also, why is it so much smaller then? I guess it's just all those scales going away, right? Okay, hold on. hold on. First, this enum flags, I always forget that. Okay. Second, this is warrior active idle 01. Right? Like, I don't see literally any scales here. I mean, maybe there's just like one at the end. That's pretty weird. So I want to know when we clear this flag, if flags and scale constant, then log scale for bone whatever became constant on sample whatever. Just put bone index up here. Bone index and it index. So that'll just give me some info. Oh. This is now called bone index. Okay. Became constant on sample 1. Sorry, became not constant. Okay, so that print is busted. So this one down here, this is weird because this is like the fidget animation. Dude, that has scale constant for frickin' everybody, right? And those flags look pretty plausible. But so these are substantially smaller. I just don't know why the active idle I don't know why. For these other animations, we didn't say, oh, the scale became non-constant, right? So let's go back and look here. It literally says, like, that's so weird. All these look fine. For this one, it's like sample 1 for bone 1. Like, what are you even talking about? I might print the values next. So keyframe 0, bone 1 is this guy. All right. Maybe memcopy is not going to be good for us. That would literally be this. Maybe the way we load these in the loading code is not good. I don't even know. Okay, I'm going to print out the values. Became non-constant. Initial value, whatever. state dot scale or log different value, whatever, scale. All right. Let's go. What happened here? Okay. It's harder to read. Maybe I should have printed it out nicer, but whatever. Okay. Initial value, different value. Oh, God. Why do we have... Okay. Why do we have sign differences in the zeros? Okay. This is weird because I don't get it. We're going to have to look at what the file format is doing because the frickin' file format just has less thans. Oh. It's maybe an old file where we're converting from global to local. And so we're getting numerical error because these values are the same out to 4 digits, right? Ish. So we're doing some stuff. Okay, so one of the things, the old file format had all the transforms in like a global-ish way, meaning that they were fully multiplied out by their parent transforms. And you don't actually want that for anything, right? It was just a guess that I made about how to do it initially that was wrong. So for this, something someone else on the team did was to switch it to be local by default. Now this particular file may not have been re-exported since then. But it says version 3. And I'm pretty sure anything past version 1 has had that change. See, I don't know, like, okay, this lists all the scales as being 1, 1, 1, blah, 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 right? Here, it says scale for bone 1 had 1.001s. It says scale for bone 4 has like 0.5 and 1.9. So maybe they're multiplying in... Okay. Let's take a look at what the code is doing when we load. Because I feel like it's going to be doing something I don't like. So okay, we read all that stuff. We go, here's all the samples. File only contains changes is version number greater than 2. File joints are relative is if it's greater than 1. So these should be, relative dealy boppers. So I kind of don't understand. So this is about looking for the less than or whatever, right? Um, and then this is doing like footstep. We're going to want to factor this apart, I think. Anyhow, um, this doesn't, like, it's reading the X form state straight in there. We can verify, read X form state. We're just pulling it out of the file, string to float. Like literally. So what is the deal? Do we do something else? We literally call this here. So like, why am I so sad now? I just fundamentally don't understand, for example, where are these numbers coming from for bone 4? Am I completely insane? Like, never mind that they're even different. Where did these come from? It looks like when we look in the file, let me make sure. Okay, hold on. We're not printing. Okay. We are not printing. I bet this isn't the warrior. I bet this is the frickin' bird, guys. I bet you this is the frickin' bird. Let's... See, when things don't make sense, revisit your assumption. What movie was that? Memento, where he says that? Okay, who is this? Bird. It's the bird. Okay. Now it all makes sense. I do think we're going to want to look at this and figure it out. Why the bird's a problem. It's probably something to do with the scale. It may be something happening in the exporter, and we're going to revisit all that separately. So I'm not worried about the bird. The warrior and stuff, this is coming out all clean and plausible. Right? We've got constant scales for him. This is all very good. So, you know, and if we need, for some reason, if that numerical error is somehow intrinsic in the math that we're doing, I don't know, we could do it at higher precision. We could add a little bit of an epsilon in there. Okay. But what this means is that I believe for now our file sizes for warrior are good. And they're smaller, right? So let's go back to date modified. Oh, we got to, oh, because I just ran around. So let's pick a random big one, like move forward to idle right is is already smaller than the old animations. They're already like half the size. And we haven't even tried much. Now, maybe it's smaller because I catastrophically messed something up, but I'm not sure that that's the case. So we're good. I am feeling like it's lunchtime for me. I'm getting pretty hungry. But what I want to do today is do at least one or two more streams on this topic where we just keep going. Maybe the next stream is going to be rearranging some of the names on the thing and some of the way this is stored to make me happier with the way I think in the year 2022. And then the code will be rejiggered for that. And then we can write the loading code for the file format that we just saved out. If you guys want to see what that looks, I mean, you know, it's Emacs, right? But so it starts, this was the start. And then from here, this is just a bunch of floating point numbers that, I mean, welcome to floating point, right? You could maybe start to see a little bit of pattern if you learn the matrix, but it at least looks kind of information dense. I mean, you sort of will notice here, we have a lot of the same numbers, right? But that's okay. There's a lot of zeros somewhere. Entropy coding will help you out with that. But like I said, it's already half the size of our old animation files, as we predicted, right? Remember I said like, oh, the ASCII is like 10 digits and the float is like 4 digits. And so if we take, right, 4 out of 10 is 40%. Whoops. Programmer 4 out of 10 is 0. So let's go back to math person. Right, so 4 out of 10 times 792 KB is 316, and we're 305. So, you know, it's approximately what I estimated there. So, yeah, I'm going to go to lunch. We'll come back. We'll do some more of this stuff. And I want to at least today have this format saving and loading and us able to play from it. I don't know if we switch the game over to using these by default. Maybe we do that. And then I make the packager use these. That could be a thing that we do because that's been successful elsewhere. Yeah, we could maybe say that that's the thing. And then after that, we start being smarter. So when we load the files, we're going to be dumb about it initially. So those times when we said, hey, the position is constant or the scale is constant, when we load, we're just going to splat them back into an array, the original size. So we don't save memory in RAM. We just save it on disk. But like I said, then the plan is going to be that we could point straight into that data once we have that data consistently, right? And then things will be different. Okay. Thank you, everybody, for coming by. We'll stream again before too long. This was a good just kick off into doing a little bit better animation stuff. And yeah, our data footprint is going to go. That would actually be like a good success for today, even if we're not working that hard, is like, look, the engine is generating these, it's using them, and we package them up and we see that our footprint went way down. That'll be good. And then, of course, we can always do more to make it smaller. Thanks, everyone, and I'll talk to you later.